Welcome, physics students, to week 2 of distance learning. So I'm going to take this video to share my screen with you and go through some of the notes that you will be looking at this week. So without further ado, let's get it started. All right, so I'm going to quickly go over some announcements. Everyone who participated last week in everything did a great job. I enjoyed reading your answers, seeing your quizzes. Make sure you keep reviewing those vocab words. A lot of this beginning of this unit is trying to get familiar with what the different parts of a wave are, so continue doing that. So I need to update that slide still, so I'm going to skip to this again. So continue to do this type of schedule. The nice thing about this class is you do not have to work every single day on physics. You can finish most of it at the beginning of the week, or if you want to put it off at the end of the week, I recommend not leaving it all last minute, doing it on the weekend, because that's when you should be relaxing. So continue to go through those things. Use your workbook. So at this point, you should have at least one column or one row filled out. If you did both activities, you should have a couple, focus question, exit question. And also, I'd like to say thank you to all the students who joined the class meetings last week. I'll do another round of those this week. It was so great to see you guys. Thank you for joining in, talking to me. It definitely helps to know that we are all still out there, not just on the other side of a computer screen. Same thing with office hours. I know that it's hard to remember all your teacher's office hours, so don't feel like you need to only contact me during this time, but this is when I plan on responding to things the most and being at my computer ready to help out. So if you think you're going to need help on anything, this is the best time to do it. And I'm willing to always start a chat or a phone call if you need more one-on-one help with anything. All right, getting into the notes for week 2. So a lot of this is going to be continued review of what we've already learned. For example, we've already gone over what a crest and a trough is in a wave. A new word, though, is we're going to have a new classification of 2 types of waves. So the waves that we usually look at in physics are what we call transverse waves. Even if it's a wave that might not look like this in real life, like a sound wave, we can still use this to model the different aspects, like the frequency and things like that. So we call this a transverse wave. The wave is moving at a perpendicular angle or right angle to the wave direction. So the wave travels this way, but it moves up and down. So this kind of a pattern. And then we also have compressional or longitudinal waves. So this is the other word we use for, 2 words we use for it. This is what we use to describe what a sound wave actually looks like, where you have compressions and the in-between space, which we call rarefactions, where in between where your compressions of our air particles are. So if you think about the symbols on a phone when you're turning it up and you see the little lines coming out of the speaker, that's kind of showing that's the vibrations moving the air in different ways. So definitely there's some cool simulations and videos that you can see how that kind of a wave moves. So again, that's going to be like a sound wave. Wavelength, we've already gone over this. So that's measuring between 2 crests of a wave. If we're looking at a compressional wave, it's going to be between 2 compressions. Wave frequency, that's another one that you saw last week. So that's how many times a wave passes a certain point in 1 second. So if this was in 1 second, you can count 1, 2, 3, 4, 5. It's like counting the peaks, I guess, of the mountains. Whereas this one's just 1, 2, and then it does finish up here, 3. Amplitude is another one. So that's in a sound wave, the volume, energy level, and that's going to be the distance from the equilibrium point that the peaks or the crests or the troughs go up from. You're going to see this word again this week, so make sure you're familiar with that aspect of a wave. So this measures the energy. We have low energy versus high energy is a higher amplitude. So that's just same slide as last week. We have a new vocabulary word, though. This is going to be related to frequency, and you'll see it in one of your lessons this week. So a period is the time needed for a wave to complete one full wavelength. So from crest to crest, it's kind of like a frequency, but it's the amount of time. So it's actually going to relate to frequency as the inverse of the frequency. So what we can do with some of these terms, and you'll see this in activity 3 where you're actually calculating things, it's a little bit of wave math. So just like in normal velocity or speed equations, speed is measured in distance over time. So in waves, we can use our measure of distance that we have, which is wavelength, which is measured in meters, and we can use time from either period, the period is an actual time measured in seconds, or the inverse, the opposite, the flip of a period, which is the frequency of a wave. And although last week we learned frequency is measured in hertz, another way you can look at frequency is in 1/seconds, or sometimes in math we use the seconds, the -1 means the same thing. So the equation for wave speed, which you will see in a lesson later on, is you can calculate it by doing either the typical one where you do meters over seconds, wavelength over period, so you have your distance over your time. Or, like I said, frequency is the inverse. So the one we typically use, because frequency is a more common measurement of a wave, is wavelength times frequency. Okay, when you do that, you still get meters over seconds, because remember, this is 1/2. There's going to be a couple more vocab words, and I'm not going to spend too much time on this because you are going to be getting it in your lessons. But we're going to also be looking at standing waves in activity 4. So standing waves have a couple of aspects. First, a reflection is looking at when you have a wave traveling, when it hits an object, okay, like a wall or something like that, if it's able to bounce back, how does it return back after that moment? So you're going to be kind of looking and seeing, does it bounce back still in the same direction, or does it flip and go in the other direction? The other wave interaction we'll look at is interference. And this is when you have two waves kind of coming at each other and what happens when they hit. So you'll see that in a simulation you're going to play around with in lesson 4. And then finally, another thing that you'll see in lesson 4 is something called a standing wave. So a standing wave is when you see a transverse wave, the one that's like this. You'll see a transverse wave that is moving. However, certain points stay fixed and the wave just kind of moves up and down. So like this. It's kind of hard to show with my hands. I don't know if you're watching me. So instead, I'll show you on here. So this is showing it with a slinky. Going to get a transverse wave started. So this is just a half of a wave, half a wavelength, moving back and forth. Then they're going to increase the frequency. So you have more waves passing. That's a full wave. Notice how this point and this point are not changing. We call those nodes. You can move it again. So you can see the wave is moving, but it's rather than like traveling like this, it's standing and kind of just flopping back and forth. So that's what a standing wave is. We're going to spend quite a bit of time on that over the next couple of weeks. So a couple of things that are important about standing waves that you're going to see in that 4th lesson, the second one for the week, is nodes and antinodes. So nodes are going to be these points right here on the equilibrium line, here, here, here. Those are your nodes, and those are the parts that are fixed. The antinodes are the tops of the crests and troughs, the peaks, you might say, and those are what are moving. So those are your maximum amplitude, and those are called antinodes. So nodes, antinodes, nodes, antinodes. And that's it. So quickly, I'll go over your activities. So the first activity is going to be focusing on using the wave equations. You have a question here that you're going to solve at the end. Just use a little bit of math. Use your calculator on your phone or computer for that. And then answer that. I would recommend when you do that in your packet, you actually show the math and how you did it, just so that I can see that you're learning the process of doing that. Here's the equation again for you, and I have some slides that help you to break down some of these concepts again. So I already went over all this, but the slides will remind you of all these different pieces. Someone asked a really good question about taking notes. I'm not going to require you to take any notes, but as you're going through the slides or listening to this video that I'm taking right now, if you have a notebook for example, your physics notebook, and it helps you to write down notes. That could be something that could be helpful. So if you're working on a slide or something else, you have notes right next to you to look at. So that's this lesson. So you'll get to the end, you'll put everything together. I have another practice problem for you to go through to solve for one of those aspects of your wave equation, and then you'll get back to your focus question. So that is your first lesson. Second lesson of the week, activity 4, is talking about standing waves. So for this one, you're going to be looking at that reflection and interference that was talked about a little bit earlier. You'll learn more about that, and you'll do it by doing the simulation. So rather than going through all the slides, I'll just show you the simulation. If you have a hard time on your computer accessing this, like if it doesn't load, first of all, remember, I know on Chromebooks, when you load these Flash players, you have to accept and allow the Flash player in order to run it. If your computer or iPad or whatever still doesn't work, then you can let me know and I'll see if I can find something else for you. There's a video that shows all of this as well, so watching the YouTube video will also be really helpful. Okay, so couple of setting things. You're going to want to have your settings set at pulse. Okay, manuals, like you have to actually do it yourself. And I mean, it's kind of fun, but it's obviously not a beautiful wave. Oscillate will just kind of be moving it nonstop. That one might be useful later. But then a pulse allows you to just send each wave down. You can play around with the amplitude, so I would recommend ramping that up so that you can actually see a high amplitude. I'd also recommend lowering your tension so that when you make a wave, it can actually move a little bit more freely. And I would turn down the dampening so that your wave can travel for more than at least one turn without it kind of dampening out and losing energy. So that's all just energy dissipating. You can turn it down to slow motion to see it happen really slowly. I feel like that's really helpful later on when you're going to be sending a second wave during the interference portion. So you can see what happens when those waves hit each other. So those are all things you can do. You can also change your end. So I'm going to restart it, where rather than it being fixed, it's a loose end. And so you can kind of use that to see how things reflect. Or you can do a no end. This honestly is the least helpful thing because when you have no end, your wave just keeps going on forever and ever out the window. So fun to look at, but not super useful on this activity. So hopefully that's something that will help you to understand some of the vocab that you're going to be getting and patterns, and then hopefully that will help you to do your final question. If you're still having trouble when you get to that, there's this video will be helpful. He goes through with the actual simulation that you have and talks about these patterns of wave interference. And then same thing with this. This is going to be a little bit more of a tricky follow-up as your exit question. So if you have any trouble with this, let me know, and definitely use your slides to help you figure that out. So that is your lessons for the week. If you have any trouble, let me know. There'll be a quiz on Friday to go over a lot of wave vocabulary. So make sure you continue using that Quizlet to review those terms, and hopefully you get a successful score on your quiz. So good luck this week, and please reach out if you need anything.